All right, welcome to the third example from section 4.6. Now, this example is just like one of the examples we did both in the video and in class on Thursday in section 4.5. In this one, we're writing a polynomial function of least degree that has rational coefficients and a leading coefficient of 1. All that means is that our factors are just going to be x plus or x minus a number, no x squareds or anything higher. Rational coefficients just means that all of our coefficients are going to be whole counting numbers. And a leading coefficient of 1, again, means when we make our factors, it's just going to be x minus 2 and x minus. We're not going to have 3x or 4x or 5x. So all of this stuff here just is giving us our rules that allow us to make sure that when we take our zeros and plug in to get the factors, it's just going to be x minus whatever our factor is, or our zero. Okay, so don't get confused by this stuff. It's just allowing us to know that these zeros get plugged right into this form right here. So before we get started, we need to remember the theorems that our conjugate theorem that helps us out with this. So first of all, let's take our first zero and just plug it into one of our factors. It's going to be x minus 2. Remember, when we get this polynomial, we're just going to be multiplying all of our factors together, and then we're going to get a polynomial function that's going to be our answer. So this second zero right here, 3 plus I, what other piece of information do we know about our zeros if we know that one of them is 3 plus I? Take a second, write it down in your notes. What is our other zero? Okay, by the conjugate theorem, you should have written down 3 minus I as one of our other zeros. Okay, so now we know 3 zeros. So what degree polynomial should we end up with as a final answer? We have 3 zeros. Okay, if you said a cubic function, x to the third power, you would be right. When we have 3 zeros, we know that we started with a cubic function. So I'm going to write on the side here what our factors should be, and then we'll check and make sure we're right. So we already have x minus 2. Remember, all of our factors are created by just doing x minus whatever our zero is. So in this case, our first one is 3 plus I. So we always write these in parentheses just to help keep track of our signs. So we have x minus 3 plus I and x minus 3 minus I. So these are the 3 factors that you should have had. And to get our polynomial, all we need to do is multiply these 3 together. Now, you can always do that as a fallback if you get stuck about simplifying these. The steps that we do a little bit later in this problem are all about making this step simpler, multiplying all 3 of these together in a simpler way rather than have to multiply 2 trinomials together and then multiply a binomial by that. You can actually simplify these 2 terms when you multiply them together. So let's go ahead and look how we do that. So just like we said, the 3 factors that we get are x minus 2, x minus 3 plus I, and x minus 3 minus I. Now, the next step, we're going to be using our difference of squares pattern to help us simplify that. So let's go ahead first. Let's distribute this minus sign and get rid of these inside parentheses. Now, when we do that, we get x minus 3 minus I and x minus 3 plus I. What we're going to do here is regroup our terms. So we see that both of these terms are common. They both start with x minus 3. So what we're actually doing is we're grouping those together in a set of parentheses just to tell us that those two terms are grouped together as one. Now, what you're going to see here is you're going to notice that if we have x minus 3 as one term, and let's call I our second term. So let's call right here, let's go ahead and call x minus 3 our first term. Let's call that A. And our second term is I. Let's go ahead and call that B. What you really see right here is we actually have A minus B in parentheses, and here, remember x minus 3 is A, we have A plus B, where I is just B. So when we group these together and we replace these with just our single terms, our letters, you'll actually see that this fits our difference of squares pattern. And remember, when we have A minus B times A plus B, that just started out as A squared minus B squared. That's why we group these together as single terms like this, because we actually want to simplify this. Instead of having these trinomials that get complicated to multiply together, we're actually going to simplify it. So let's just go ahead and substitute back. A is x minus 3. So that's just x minus 3, and we're squaring that whole thing. And remember, b is just I. So we're going to call that, let's put it in parentheses so we remember. It's ugly parentheses. So we simplified this whole ugly expression right here. We were able to remember our difference of squares pattern and work backwards. And we simplified that down to x minus 3 squared minus I squared. And again, if this part confuses you, go back and watch these steps a little bit slower and try to understand that all we're doing here is we're grouping together these terms because they help fit a pattern that's going to help us simplify this. Okay, now let's go ahead and move forward now that we have that and see what we do. So now we go ahead right where we left off. We have x minus 3 squared minus I squared. And when we go ahead and FOIL this out, we get x squared minus 6x plus 9. And remember, I squared is just negative 1. We worked on that a lot earlier this chapter. Remember, I squared is just I times I, which is square root of negative 1 times square root of negative 1, gives us negative 1. Now, when we go ahead and combine like terms, we get x squared minus 6x plus 10. Now, all of this work right here, we were able to transform this long trinomials multiplied together into just one simple trinomial. Now, through polynomial multiplication, whatever way you like it, whether it's distributing each term or multiplying vertically, when we multiply these together, we end up with this long expression. Now we can go ahead and we need to combine like terms to get one single polynomial. When we multiply that together, we get x cubed minus 8x squared plus 22x minus 20. And that right there is our polynomial function of least degree. We've got rational coefficients and a leading coefficient of 1. Now you always want to check your work. Remember, on a test or a quiz, you never want to turn it in early. In math, you always know if you got your answer right or wrong. So we can go ahead and if we plug in each of these zeros, so if we plug in 2, if we plug in 3 plus I, and we plug in 3 minus I, we should have them equal to 0 each time. So when we plug in 2, go ahead, pause right here, make sure that all this math is right and see how it equals 0. When we plug in 3 plus I, you'll go ahead and see that when we work it all out, it's going to equal 0. And you'll also see that because of the conjugates theorem, then if 3 plus I equals 0, then 3 minus I always equals 0. We know the complex conjugate theorem tells us that if this equals 0, its conjugate has to equal 0. So the fact that this equals 0 tells us that both of these right here have to equal 0. Okay, again, if any of this is a little confusing, make sure you go back and watch. This right here is the same as example 3 that we did in the previous section. Make sure you go back and try to write this down on your notes. You should be taking notes as we go through this. And the checking your work, make sure you do that, because look, after we do this, we know by plugging in the zeros that we did the correct work and this polynomial is the right answer.